Hello everyone. So in today's problem, we look into the problem of the resultant force and its location. So first we look at the system that we have. We said that we have a control lever is subjected to a clockwise couple of 80 Newton meter exerted by its shaft at A. So basically in this system, we only have one external force, which is 200 Newton here. So in this uh, 200 Newton force make or generated the moment at point A to be 80 Newton meter. So if we find the perpendicular distance from the line of action of 200 Newton to point A, for example here, D, then we will be able to track back on what x is equal to. But in this particular question, because they didn't provide us the full angle of the incline that shown here, so I think the better way to solve this one, we should use the just force translation and the couple moment concept would be more suitable. So first, let's start by derive what we know. So the problem say the moment at point A is equal to 80 Newton meter. If you look closely, this 80 Newton meter is basically the resultant moment that's what generated by 200 Newton. So we will call it M total or M resultant. Okay. Then they asked about the x direction, x dimension here from point A to the curve point. We call it point B. So point A to point B, dimension equal to x. We have to find that so that the resultant force will act or will pass through point A. Okay. Okay. So first, let's start with uh, translation of force. So again, like previous question, we try to translate 200 Newton force from the end of the shaft to point B for easy calculation of dimension x. Then call it 200 Newton. So if you remember, if we translate the force like this, we should add the moment that was generated by the previous force location. For example, point B is here. That means 200 Newton force here. So this force will generate counterclockwise moment. We have to calculate that and call it MB. MB. So MB equal to 200 Newton times 150 millimeter. Then we will get moment B equal to 30 Newton meter. After we done that, we can remove 200 Newton from the end of the shaft here to avoid any further confusion. Okay, then after that, in the system, the resultant moment is still the same, which is MRS equal to 80 Newton meter, but this time we have translated the force from the end shaft to point B, and that therefore generate a moment of B, MB. So that means this resultant moment will equal to MB plus the moment that should generated by the translated force, like this one. Okay, so I will leave this one here, moment generated by 200 Newton here as let's say mx, for example. Okay, so far we know mb, right? But we don't know mx, and mx in this context will have interfere or will involve with this dimension x. You may ask, why is that? So if we look closely, if we're able to distribute the force to this direction and this direction, we will see that if the force here, for example, maybe 400 Newton, for example, it will be multiplied by distance x to get the moment of mx. Okay, that would be the way for us because we know mb here 30. So basically mx that we will have is will be equal to 50 Newton meter, and that's the way we will calculate distance x right here. Okay, let's go with that approach. So we'll derive it mx here. Mx equal to we have to distribute the force like this direction first, okay, and this direction. Those two are perpendicular to each other. Then we look closely, we try to determine the angle here. So first, this is perpendicular to this line, and this one has 20 degree angle. So that if we choosing this perpendicular line, that means the inclined angle here should be the same. So we write here 20 degrees. Okay. So then if we distribute it here, perpendicular force like this one, we call it maybe Fy naught equal to 200 times cos 20 degrees, and we call this one Fx naught equal to 200 sine 20 degrees. Now, in this case, you may already know Fx naught doesn't generate any moment because it passed through point A, so we will not calculate that. So that means mx that we have equal to Fy naught time x direction, because x direction is the only direction dimension that is perpendicular to Fy naught. Now, we already know previously that mrs equal to mb plus mx, mrs equal to 80, mb equal to 30 plus mx. So that should give us mx equal to 50 Newton meter. Then we substitute this value into this equation. So we will get 50 equal to 200 cos 20 times x. Then if we calculate this one, we will got x equal to 266.04 millimeter. Okay, so now that we conclude this question, I hope you learn how to solve this problem in the static ways, and I will see you guys in the next problem. Thank you.